Hello, friends. This worksheet looks at what we call Bronsted-Lowry acids and bases. And in a Bronsted-Lowry acid and base, you have a substance that's an acid, a substance that's a base, and then on the other side you have what is known as a conjugate acid and a conjugate base, but you can also just call them acids or bases as well. They pair together. An acid from this side pairs with a base on that side to make a conjugate acid-base pair. In this one, you're just going to label what the acids and bases are. Technically, once you find one, then you know all of them. But you can just double check always when you're doing it, of course. So what you do is you look at the first thing or the second thing or whatever. HNO2 is this one. And you're going to compare it to something on this side. So what on this side looks like HNO2? Well, it's this one. It's missing an H, and the charge is down 1. And so you have to remember, for acids, acids will lose an H, and the charge goes down by 1, and bases will gain an H, and the charge goes up by 1. So if it was HNO2 here, then it became NO2 minus 1 there, then this is the acid. So you write an A there for acid. And then now once you know one of them, then you could do all of them, but you can always double check too. So it was H2O here, now it's H3O plus, so it gained, so it's a base. And then if you read it right to left, it was H3O here, but now it's H2O there, and so there's your acid. It lost the H, and of course it was NO2 here, but now it's HNO2, so it gained and the charge went up by 1, so there's your base. And then these are the pairs, the acid on one side and the base on the other side. We call those conjugate acid-base pairs, and there'll be 2 of them for each problem. There's this pair and then also this pair, base, and it's conjugate acid. Okay, so now that you have kind of, know all those things, you go a little bit faster with them. So HSO3 minus here, it's SO3 minus 2 there, it lost, so there's your acid. CO3 minus 2 has, it's right here's HCO3 minus 1. Of course, it's going to go up, gained an H, so there is your base. And on the other side, they just get flipped, but you can double check always, of course. HCO3 became CO3 minus 2, so it had a minus 1 charge, it lost an H, and the charge went down by 1 if you read it right to left, and so there is your acid. And then here, SO3 minus 2, if you read it right to left, it starts here, and it gains an H, and the charge goes up by 1, so there is your base. And again, this worksheet doesn't ask you to do it, but these are the conjugate acid-base pairs, an A and a B, and an A and a B. Technically, if you wanted to, you could call these CA, CB, CA. Just so you know that an acid will always have a conjugate base, and a base will always have a conjugate acid. If you read them either direction. Okay, so NH4 became NH3, so it lost an H, so it's an acid. OH minus became H2O, it gained, so there's your base. And then going other way, the roles just get reversed. So it is NH3 here, but now it's NH4 if you read it right to left. So there is your base, and this would be your acid, and you can call them conjugates as well. You can just call them acids and bases too on that side, but either way works fine for me. The other kind of problem you see for these are ones where you're just saying what the conjugates are for each of the things. So if you're looking at a list, and this one says bases, you need to remember that bases always gain an H, and the charge goes up by 1. So if you're writing conjugate acids for these bases, if these are all the bases, then all of them, the conjugates are just where you add an H and the charge goes up by 1. So for each of them, that's what we'll do. So HPO4 minus 2 becomes H2PO4 and minus 1. Charge goes up by 1. HCO3 minus 1 becomes H2CO3. Add an H and the charge goes up by 1. HNO2 becomes, NO2 minus 1 becomes HNO2. And then ClO2 minus 1 becomes HClO2. And then you do the opposite for the acids, of course. If these are the acids, acids always will lose an H and lose a charge. So if it was HCN, now it's Cn minus. You lost an H and the charge went down by 1. H2SO3 becomes HSO3 minus 1. HSO3 minus 1 becomes, oopsies, SO3 minus 2. That's terrible. I'm a bad teacher, and I apologize. HNO2 becomes NO2 minus 1. HF, hydrogen fluoride, becomes just the fluoride ion. And HClO, which is neutral here, becomes ClO minus 1. Okay, so you've got kind of 2 problems when you're doing conjugate acids and bases, Bronsted-Lowry acids and bases. One is identifying them in a reaction, and then the other is given if it's a base or if it's an acid, could you list its conjugates? And that's just remembering that acids always lose an H and a charge, and then bases always gain an H and a charge. There you go. Bronsted-Lowry acids and bases. This has been fun. Okay, bye.